Hello everyone, welcome to this tutorial session. My name is Pratham Goradia and I am an AI developer at MakerBay. So MakerBay is a non-profit based in Hong Kong, and what we try and do is develop real-life maker skills within the youth community in Hong Kong, so that they themselves can, go on and develop real-world solutions to the sustainability and social problems in their local communities. So yeah, welcome again to this tutorial session. And today we are going to teach you how you can make your own AI-based image recognition mobile application. And this tutorial is going to be really beginner friendly. The tools that we are going to use, they're either no code tools or block coding tools. So you don't really need any past experience or prerequisites to follow along through this tutorial, and hopefully by the end of this session you will be able to make your own similar application. So yeah, with that, let's get started. Now, we were really inclined towards using open data for this tutorial, and the reason for that is open data is freely available out there on the internet, and anyone can use this data to develop their own AI or big data or IoT applications. And for this reason, open data is a really powerful resource that even you guys can use to um, combat social and environmental problems that are out there today. Now, open data can come from a lot of sources. Um, One of them is scientific institutions, and um, they release open data in order to, encourage the people to use that data and try and develop their own AI solutions using that data. So, for example, here you can see this is the open data portal for NASA, and it provides a lot of interesting space data. And this is another open data portal by a scientific institution, which is the Cancer Imaging Archive. And they have a lot of data sets with medical images specifically related to cancer, and they hope that researchers or AI engineers out there can make useful applications using these data sets. Another source of open data is government bodies. So, for example, here you can see this is the Hong Kong government's open data portal, and they have a lot of data sets in different categories. So here you can see city management and the weather data, education data, and stuff like that. On the top right, this is the um, data portal of US Census, and they have a lot of economic and population data. So, for example, you can see business formation data over here and international population data. And on the bottom right is another government institution in Hong Kong is the Lands Department of Hong Kong, and this data portal gives access to a lot of geo data or land data within Hong Kong. Finally, even international organizations uh, release a lot of open data sets. So, for example, again, here you can see UNICEF, World Bank, over here, World Health Organization. They all have their data portals, and they make um, a lot of statistical data open to the public for research analysis, and hopefully getting insights out of this data, which can help improve society. So these are two of the most popular, um, search engines for getting data sets. This is Kaggle.com, and it has a lot of interesting data sets. Uh, and this is Google Dataset Search, and this is more appropriate if you already have some kind of topic in mind that you want to try and obtain data sets for. So yeah, it's similar to the Google search engine, but specifically for data sets. So yeah, hopefully you guys can use these resources as well, and hopefully find interesting data sets related to topics you care about or problems that you're interested in solving. Now, for this tutorial, because we at MakerBay are more focused on, solving projects related to ocean conservation or ocean resource management, we wanted to pick a data set that is related to that topic. So we chose an open data set of images of coral species. Now, before we dive more into that data set itself, let's try and understand what coral reefs are and why they are so important for the oceans and the environment in general. So, in singular terms, they're known as coral polyps, and a coral polyp is a marine animal. A lot of people get confused whether they're plants or animals, but they in fact are animals. However, they are sessile creatures, which move, and this means that they cannot move. They are stationary and they stay in the same spot for their entire lives. Now, the special feature about these animals is that they develop these hard calcium skeletons, and this is their most prominent feature. So, even in these three images, uh, what you're seeing is the calcium skeleton developed by that coral animal. Now, coral polyps are colonial animals, which means that they live in colonies or in groups, and a colony of coral is known as a coral reef. So when a coral polyp dies, it actually leaves its exoskeleton behind, and new coral is formed on top of this exoskeleton. So over time, as generations of coral pass, the coral reef keeps getting larger and larger in size. And this is actually one of the properties that makes coral reefs so advantageous for the environment. So yeah, let's move on and understand why coral reefs are so important for the environment. Firstly, because of their large size and uh, their structure and stuff, they provide shelter to a lot of marine animals, and they are some of the most biodiverse environments anywhere on Earth. Even though they only take up 1% of the space in the ocean, 25% of all marine life at some point in its life cycle is dependent on coral reefs for survival. Secondly, there in coral reef ecosystems, there is a lot of algae which is able to live in this kind of ecosystem. And what this algae does is that it carries out photosynthesis and provides oxygen for the ocean. Now, in the ocean, there is not a lot of sources of oxygen. So, for marine life to breathe and survive, it is very important for coral reefs to exist so that there can be enough oxygen within the ocean. And lastly, for beaches or landforms along the coast, or even human communities that are situated along the coastline, coral reefs provide a natural barrier for them, which protects them from tropical storms or large waves or land erosion along the coast. Now, unfortunately, because of a lot of factors which are caused by humans, such as climate change or water pollution, the levels of corals in our oceans have been declining year by year. And this is affecting the entire marine ecosystem, which in turn is affecting the environment and the global ecosystem. And it is definitely going to impact us soon as well, unless, we are able to make changes and try and conserve the these very important and biodiverse ecosystems present in our oceans. This is, an example of what a coral reef looks like, and yeah, you guys can um, obviously see the biodiversity that is present in terms of the different species of coral itself, and along with that, even all the different species, such as all these fish here, which use this coral reef as their home and for survival. Now, moving on to our data set. Our data set was called the Structure RSMAS Coral Species Images Dataset. It was prepared by SCI2S, which is a research group uh, within the University of Granada. And These are some example, images from the data set. So the data set contained 409 images of 14 different species of animals. Uh, and these words in the brackets, they, this is how these images were labeled. And what these words are is that they're keywords which represent the species of these animals. And all of these 14 animals weren't necessarily coral species. Some of them were even other sessile creatures which are found in coral reefs and are often confused for coral themselves. So, for example, this animal that you see here isn't coral, but it's actually sea urchins, which are very popular in coral reefs. And similar, this animal here is again, these are tunicates, which are different from corals, and they are, more commonly known as sea squirts. So again, even these are different animals and not necessarily coral. These are again more specific examples of what the data set looked like. So once you downloaded the data set from the website of University of Granada, uh, you had these 14 different folders, which represented the 14 different species, and in each folder there was between 15 to 30 images uh, of that specific species. So for example, in the first folder, there was these 42 different images of this particular species. So now that we have a better understanding of the importance of coral reefs and what data set we're using for our AI application, let's get a better understanding of what exactly our AI application is going to be. So how we're going to use this data set is that we are going to make an image classification program. Now, what exactly is image classification? So image classification is a type of computer program where there is these different categories known as classes, and you provide an image to a computer, and the computer tells you which of the classes the image belongs to. So for example, if you see in this example over here, for the first image you provide this image to the computer, and then the computer tells you that it is most likely that this image belongs to the category called might. And then it also comes up with these other categories which are less likely that this image belongs to. So um, its main prediction is that this image belongs to the might category, but it might also be a black widow or a cockroach, but those are less likely, as you can see by these horizontal bars here. Those are less, they have lesser probability than this image being a mite. And similarly for the examples here, the computer predicts that this image is most likely a container ship. This is most likely a motor scooter, and this is most likely a leopard. So currently, one of the most effective tools for developing image classification programs is machine learning. And machine learning is a type of AI, and it is a very powerful and effective tool, especially for these kinds of problems. And this is where the AI of our project comes in, is that we're going to be using machine learning to develop our image classification program. And the way machine learning works is very similar to how humans learn, and that is why it is considered a type of artificial intelligence. And for example, if you had a human baby and its parents showed it an image of a dog and pointed it out and said, "This is a dog," and as the parents showed that baby more and more dogs, the baby will eventually be able to look at a dog and automatically classify it as a dog, or whenever it sees a new image of a dog, it will automatically be able to understand that this is a dog. And similarly for machine learning, Instead of how babies use eyes to look at the dogs, the machine learning program uses what is known as an input layer, through which we pass the images to this program, or the pixels of the images to the program. And along with the image, we also pass the class that the image belongs to. And using these what are known as training images or example images, the hidden layer, which can be compared to the brain of the baby, a lot of math goes on here, and the hidden layer slowly starts to understand um, how to differentiate between the classes of all the images that it is provided with. And eventually, once we train this program enough, and we can pass a new image through the input layer, but this time without telling the input layer what class the image belongs to. And as it passes through the hidden layer and comes out from the output layer, at the output layer, the computer program will itself be able to tell us which class that particular image belongs to. So yeah, if all of this seems a little confusing right now, yeah, don't worry. I'm sure as we move forward with developing the program itself, it will get clearer. And yeah, it's not really necessary to understand how machine learning works, like behind the scenes, the algorithms and the maths behind it. In order to, uh, even if you don't understand that, you can still use machine learning and make useful applications out of it. So yeah, coming back to our application, what we're going to make for the AI part of our application is an image classification program, and the goal is that uh, we will give completely unseen or new images of coral polyps to this image classification program, and it should be able to correctly classify which of the 14 different species that we have, which of those species that image belongs to. And yeah, let's get started. So now let me take you guys through the process of how we develop this application. So the first tool that we used is known as XSimilar or similar. I'm not really sure how it's pronounced, but yeah, you guys can note it down. This is how it's spelled on the top left over here. And this tool allows us to develop our own image classification program without using any code. And this is what, once you sign up and log in, this is what the dashboard will look like. As you guys can see, apart from image classification, which over here is also known as image recognition, there are a lot of other machine learning programs that you can make using this tool. For example, object detection, which is where you provide an image to the computer program, and it can tell you what objects are present in that image and where exactly are those objects in that image. So yeah, even that is pretty cool, and you guys can try it out, uh, you, later when you're using it by yourself. But coming back to our application, so yeah, we're going to do image classification. Again, over here, it's known as image recognition. So we start by launching it. Next, we go to tasks, which is basically a list of all our image recognition projects. As you guys can see, I have already developed uh, an image classifier before the tutorial started. But just to show you guys how it works, I will, go through it, some of it again. So for image classification, there's two different types. One is categorization, where an image can only belong to one class, and the other is image tagging, where an image can belong to multiple classes. So for our application, one animal can only belong to one species. That's why we are going to select categorization and continue. So over here, you can give your project a name. I will name this Coral App Tutorial. So as we discussed, in order to prepare a machine learning program, you give it a lot of example images along with the names of the classes of those images, and then you train it. And once it's trained, the machine learning and you give a new image when you give new images to the machine learning program, it can tell us which class that new image belongs to. So we're going to go through that entire process right now. So in our data set, there's 14 different classes, or also known as categories, and we start by creating our first category. So we name our category. So similar to our data set, we will call our first category Acer. If you guys remember, in our data set, the first category was also known as Acer. Uh, you click over here to upload images. So this is our entire data set. There's 14 different folders, and I'm going to go to the first folder, again known as Acer. Press Control A to select all the images that belong to this category and upload them. So yeah, you do the same thing for all the different categories that are there in your data set. And let me go back and show you guys. Um, Yeah, so as I said, I already developed a classifier before the tutorial. So let me show you guys what it looks like once you have created all the 14 different categories and uploaded all the images that belong to their respective categories. So yeah, so this is what it will look like. And as you guys might have noticed over here, there's just 13 categories, even though in our data set there's 14 different categories. And that is because XSimilar needs at least 20 images in each category in order to be able to train the machine learning program. And one of the folders in our data set did not had lesser than 20 images. It had around 15, 16. So yeah, that is one of the limitations of XSimilar, but I think it's not that big of a limitation because you can always go online and find more images that belong to that class, and have at least 20 images for each class. um, so yeah, you guys can try it out later as well if you guys make a similar program to try and add all the 14 categories instead of just the 13 we have here. So yeah, once you guys add all your classes that are there in your image, the next step is to train your. So these are all the example training images that the machine learning program will use to learn. And how it learns is that you click on the train option over here. Now over here, I have already trained it once. That's why the button says retrain. But if you haven't trained your program yet, it will give you an option to train. So you click on it, and it takes some time. It takes like around 15 to 30 minutes for your machine learning program to use all these images and train itself. And once it has completed training, this is what it will look like. It will show you the accuracy, like how accurate your machine learning program is. Over here we have 87%, which is decent, but ideally we would want it to be more accurate. And what we could do to make it more accurate is to add more training images in each class, so that it has a more diverse data set to learn from. It can learn it can more accurately learn the specific differences between each class if it has more images to learn from. um, yeah, once your model is trained, you can also test it. So over here, if you click here, um, so in order to test your model, you should use images which were not used to train your model, and only then you can see if your machine learning program works accurately. So over here, you click here again, and as you guys can see, this is my original data set, which was used to train the model. But then I have another folder known as test, where I took some images from the internet and created a test data set, which is different from the training data set. And you can upload up to 10 images at a time. So I'll select these first 10 images. Yeah, once you upload them, you can click on process here and test your machine learning model. So yeah, you can create your own test data set, which has to be different from your training data set, using images from the internet from any other source. And you obviously know what classes your the images in your test data set belong to. I've named them accordingly here. The first one belongs to MDM, the second belongs to, this Pali class. Um, so that way you can see how accurate, you can see for yourself how accurate your machine learning model is. So over here, similar to the example we had in the in our presentation, it gives you the class and the probability that, this image belongs to this class. So yeah, this is how you can test your model for yourself and see what percentage of images in the test data set your model is able to classify accurately. So yeah, as you guys can see, it made predictions for all the 10 different images. And yeah, I won't go through it right now, but this program that I made over here, it got 9 out of these 10 images um, accurately when I checked earlier. Like 9 out of these 10 images were predicted accurately. So yeah, that is a pretty decent accuracy. Of course, ideally we would like some higher accuracy, but I think for now it's okay. It can always be improved. Um, So now that uh, we had our image classification AI program ready, which was able to classify between the different species of animals, our next step was to build the uh, mobile app itself. So yeah, let's move on to that. So the next tool that we're going to use is known as Thunkable. You guys can see this is how it's spelled over here on the top left, and yeah, you guys can note it down. And Thunkable is a very useful tool which allows you to develop mobile applications without using any coding. And yeah, once you guys sign up and log in, this is what your dashboard would look like. Of course, I already have a lot of projects from earlier over here, but you can create a new project by yeah, clicking here. You can give a name to your project and um, yeah, I think the drag and drop interface, I think it's still in the beta version. So for now, I would avoid using this interface. So I would not check this. And yeah, you just name your project. If you want to give some category, you can give it and you create it. Um, so the project that I created for this current tutorial is this one, H classifier. So yeah, this is what it looks like, the interface, and mainly there are two main sections to Thunkable. First is known as the design section, wherein you add all the components your mobile application is going to have. And as you can see, there are a lot of components over here. Uh, and you use the design section to add all the components and to uh, you can give properties to the components over here, and you kind of use this section to decide how uh, the application will look like, what the design will look like, where the different components will be placed and stuff. And the next is the block section, and this is the section where all the behind the scenes stuff goes on, right? So in this section, you actually get to uh, d- uh, tell the app what to do, different components are clicked and stuff like that. So as you can see, um, you use block coding to program this app. If you guys have used Scratch earlier, then it's similar to what's used there. So going back to the design section, so as you guys can see, I have one screen in my app. Uh, I have an upload button over here. So this button, and I'm going to use this button to let a user upload an image from his gallery, and the app tells the user which species of which of those 14 species that image belongs to. The next is this button, the capture image button. And with this button, instead of uploading an image, the user can use his camera to take an image right there, and the app tells us what species it belongs to. In order to show the outputs, I have an output label, but I have set it as invisible right now. But yeah, it's over here. And when the app does its processing and returns the output, um, that is when it will be set as visible. But for now, I'm leaving it invisible. And similarly, I also have an image component. Um, so this will be used to show the user what image he uploaded or captured using the camera. But again, for now, it's set as invisible. Um, then there are some hidden components, which it's not possible for the user to see. So this is the photo library component, which allows the user to which allows the app to access the user's gallery when required. Again, the camera component, which will be used to capture the image when required. Right. So the next component that I have added to my application is known as the Web API. Now, this is an important component. So, what is an API? An API, which stands for Application Programming Interface, is a tool which allows two different pieces of software to communicate with each other. So the API is what we are going to use to connect our machine learning program that we developed in XSimilar to our Thunkable mobile application. Now, usually APIs have three main parts. The first is the URL that you're going to call. The secondly is the header of the API, and the last is the um, body of the API. So we'll go over to the documentation in XSimilar, and in the image recognition section in the API documentation. As we can see, there is the classify endpoint, which is the classification feature of the API. There is an example here of how it can be used. Um, so this is using the command line or SSH, but since we're using it in Thunkable, we'll just use it as a reference. So the dash h here means that this is content that belongs in the header. So in the header, there are two things. Firstly, we have to specify that the content type is application or JSON. And secondly, we have to provide our authorization. So in the header, we have to provide our API token. And this token, it can be found in your tasks. If you go to your machine learning program, the token can be found here. And if you click here, you can look at the token. So again, going back to Thunkable, in our API component, in the headers section, we have added the content type. We have specified that the content type is application/JSON, and we have also provided our authorization token along with the token number. Going back to the documentation, um, so we can see here this is the URL that is used for the classification. So in the URL section of the API, we have added the same URL. And finally, this is the body of the API request. And in that, you mention the task that you are using. So again, over here, for that, you can use the ID over here, the task ID. And lastly, you provide the URL of the image that you want the API to classify for you. So now that we understand, so we will not add the body section over here because right now we will only get the image once the user uploads it. So we will do that in the backend section. And finally, MediaDB is just an online database that allows us to upload images. We can upload images to this database and get the URL of the image. Without using this component, we would not get URLs for images because we would not be able to upload them online. So finally, I will just go through the block section and how we programmed all the different components of our app, the buttons, the labels, the API, the MediaDB camera, all of it, how we programmed it and how we set it up to work together. So let's go through that. Again, this uses block coding, so it's easier than regular coding and it's also a lot more intuitive and understandable. So let's just start from the beginning. So when the user clicks on the upload button over here, we call the photo library component and we allow the user to select photo from his device in the gallery. Now, if there are no errors or if the user did not cancel, we call the MediaDB, which again is the online database. We call the upload function of the MediaDB component. Uh, and we take the image that the user uploaded from here and upload it to the MediaDB, to the online database. Once the image is uploaded to the online database, it returns the URL of that image, the online URL of that image. So again, if there are no errors over here, we um, we set the input image as the image that the user selected from his gallery. Now we create the body section of the API. So again, as we saw over here, firstly, so we can add this section, the records list, which specifies the URL of the image. So we add the records part, and then we add the URL that the MediaDB online database returned to us. And finally, we add the task ID to the body of the API. So as you can see, set web API is body 2, and then we combine these pieces of text and we create the body of the API. Now we have specified the URL of the API, the headers needed in the API, and the body of the API. So finally, we can call um, the post command from the web API component, and this means that we have given all the inputs and we are executing our query now. So uh, when we call a post command on an API, the output that we get is known as the response. So again, if there is an error, it will show an error, but if there are no errors, um, yeah, we get the response back, and the response is not really just a one word response. It's actually something known as a JSON object, and it gives us a lot of information back, like the processing time, the status of the request, and stuff like that. But the only thing we are interested in is the best label and the name of the best label. Right? So the best label specifies the most likely class that our image belongs to. So in this example, they were using dog and cat, but in our example, there's 14 different classes, and the best label uh, uh, section in the response will tell us uh, which is the most likely class that our image belongs to. So from the response, uh, we like manipulate the entire response. We get the firstly we get the record section from the response, then from the record section we get the best label section, so which is this one, and finally from the best label we get the name section. Once we have the name section, we set the output label component, which we had in our design. We set it to the name. Finally, we make the output label visible because if you guys remember, we had set them as invisible because there was nothing to show at that time. But now that we have received an output from the API and we can classify the user's image, we set it as visible, and we even set the input image component as visible, so the user can see and make sure see what image he selected and make sure it was the correct one. Finally, this is the last piece of code we have in the backend section, and it is the exact same piece of it does the exact same thing, but instead when the camera button is clicked, instead of the photo library, we call the camera's take photo function. Uh, so when the camera button is clicked, the user is allowed to take a photo from their phone. Again, if the user did not cancel or if there are no errors, we do the exact same thing. We upload that image which the user took from their phone to the online database called MediaDB. Once the image is uploaded, it outputs a URL to us. If there are no errors, we take that URL and we use it to create the body of our API request. Once our API body is created and set, we call the API's post command, which returns the response to us. Again, if there are no errors, we take the response, get the best label section from the response, get the name of the best label, and show it in the output label component. Finally, again, we make the output label and the input image components visible. So just to go back to the design section, this is the upload image button. This is the capture image button. This is the input image component, which was originally set as invisible, but once we are showing the output, it will become visible. And the same for the output label component. When we show the output, it will become visible. So yeah, our app is ready. Our machine learning program is ready. We have combined them all together. And in Thunkable, when everything is ready, you can click on download here, click on iOS or Android, whatever OS app you want, enter your email, send it, and Thunkable will email your final ready app to you. Yeah, so I will share the link of this Thunkable project with you guys. And once you guys make your own Thunkable accounts, you guys can access a copy of this project and um, go through the design and the coding blocks and stuff in more detail later. So finally, Thunkable even has a separate mobile app which allows you to test the apps that you're building in real time. And I used that to test out this app that we built right now. And yeah, I will show you guys a screen recording of what it looked like. So I clicked on the upload image button and uploaded an image as downloaded, which belongs to the first class, the Acer class. Once I uploaded the image, yes, this is the output that you receive. So it shows us what image I uploaded and shows us the name of the most likely class that the image belonged to. So thanks a lot for watching, you guys. I really enjoyed preparing this tutorial for you. I really hope you guys were able to learn something useful from it, especially in terms of the tools you can use to make your own AI-based mobile apps. Both of these tools that we use, XSimilar and Thunkable, are really intuitive. So I would really encourage you guys to, just get started with using them, and I'm sure that you will be able to figure stuff out as you go along. Um, so again, thanks a lot and best of luck.